Hello everyone, myself Rakesh K. I am from Sri Venkateshwara College of Engineering. My USN is 1VE23EC085 and the section is AstroSat. Today's subject is a mathematics for triple E stream and the subject code is BMATE C301 and the topic is how to represent the signals in the Fourier transform. The first slide we have deconstruction signals, a guide for Fourier transform. These presentations delves into the world of a Fourier transforms, exploring their fundamental principles and practical applications. Well, we unveil how these powerful mathematical tools provide a deeper understanding of a signals by breaking them down into their constant frequency. The second slide we have an introduction to Fourier transform. In that we need to study about what is Fourier transform, what is the importance of a Fourier transform and applications of a Fourier transform. Fourier transforms are a mathematical tool used to analyze and represent signals in terms of a frequency and contents. The importance is they offer a way to decompose complex signals into simpler complex, making them to easier and understand their behavior and properties. This is the importance of a Fourier transform, and the application is Fourier transform find applications in diverse fields including signal processing, image analysis and physics. This is about the introduction. In the next slide we have a understanding periodic signals. In that we have repeating patterns, examples and key characters. The first point is a repeating patterns. Periodic signals are those that repeat themselves at the regular intervals, and the second point is examples. Examples include sound waves, alternating currents and the light emitted by stars. And the third we have key characteristics. The fundamental period is the smallest time interval over which the signal repeats. This is about the understanding periodic signals. The next slide we have a representing periodic signals with Fourier series. In that we have a 3 points: Fourier series, harmonics, coefficients. Fourier series. The Fourier series expresses a periodic signals such as periodic signal as a sum of a sines and cosines at different frequencies. The second we have a harmonics. These frequencies are integer multiples of a fundamental frequency of the signal. And the third we have a coefficient. Each harmonic has a corresponding amplitude and phase determined by the Fourier coefficient. It is the next slide we have extending to a periodic signals. In that we have a 3 key points: a periodic signals, challenges and the solution. Let me study about the periodic signal. A periodic signal do not repeat themselves over time and have no defined period. And the challenges, direct applying Fourier series to a periodic signals is not possible. And the solution is the concept of a Fourier transform addresses this by extending Fourier series to periodic signals. This is about this slide. The next slide we have a Fourier transform of a periodic signals. In that we have a frequency spectrum, amplitude and the phase. Frequency spectrum is nothing but it is a Fourier transform of a periodic signal yields a frequency spectrum. The next point we have a amplitude. Amplitude is the spectrum at each frequency indicates the strength of that frequency component. And the next we have a phase. The phase of a spectrum at each frequency represents the phase shift of a component. This is about the Fourier transform of a periodic signals. The next slide we have a partial practical applications of a Fourier transforms. The 3 points are signal processing, image analysis and medical imaging. Signal process is nothing but analyzing and filtering signals such as audio, radio waves, and seismic data. Image analysis is nothing but enhancing image quality, detecting edges, and compressing images. The next point we have a medical imaging, analyzing medical signals like EKGs and EEGs to diagnose and monitor health conditions. This is about the practical applications of a Fourier transform. Let me study about the limitations and assumptions of a Fourier transforms. And the first we have a stationary signals. The second we have a limited time resolution and non-linearity. Non-stationary signals is nothing but the Fourier transforms assume signals are stationary at constant staticals properties. The second we have a limited resolution. Fourier transform provides frequency information but not precise timing information. At the third we have a non-linearity. Fourier transforms may not be suitable for analyzing non-linear signals or systems. And the last we have a conclusion and key takeaways. Fourier transforms are a powerful tool for the analyzing signals by decomposing them into frequency components, and understanding these transforms provide valuable insights for various applications in science and in engineering. And behind that, although limitation exist, and these techniques remains instrumental in signal processing and related fields. This is about all the how to represent signals in Fourier transforms. Thank you for watching. Like and subscribe.